marble and you put it in a box and you shake the marble around, it can have any old kinetic energy it wants. It can be going fast, it can be going slow, it can be going at a continuous amounts of velocities in between. That's not true for a particle that behaves like a wave. Particles that behave like a wave can have only certain energies. The energies are quantized. Remember, wave plus boundaries gives you quantization. So I have some quantized levels written here, and quantization is the fundamental property that allows absorption and emission of light. Because if you're going to make the system go from one level to the next, you can't absorb just any old wavelength. You have to absorb the wavelength that actually fits, that gives you the exact amount of energy to go from low state to high energy state. All other energy levels and all other energies that the system experiences will be ignored, but energies that fit its energy map, energies that map onto this, will be absorbed or, conversely, emitted. So here's a wavelength, high energy wavelength, exposed to that system, but there's no spacing, energy spacing, equal to that energy. So that is transmitted. Here's a wavelength that exactly matches this high energy transition. That one will be absorbed. And when it's absorbed from the spectra, you see it's missing in the continuous band that's being exposed to the matter. That wavelength is absorbed. You'll get a dark area where that wavelength is absorbed because the system has an energy spacing that matches that frequency. And of course, atomic and molecular transitions work like this. You'll have some wavelengths that will pass right through, some wavelengths will be absorbed. It's like the Goldilocks principle of atomic absorption. Some wavelengths are too big, some are too little, some are just right. So you have another just right, that will be absorbed, and perhaps you'll find a third just right energy level that will be absorbed. So you get an absorption spectrum that says, oh, this blue, this yellow, and this red are removed from the continuous light that's hitting this object. Or you could have the light emit by the system. The system could emit the energy of the high wavelength, and then you'd have a single emission. It can't emit all wavelengths of light. Only certain wavelengths of light are emitted. And this is why things can have certain colors, because they'll emit certain wavelengths of light. Here, at this example, a blue wavelength, a lower energy green wavelength, and a still lower energy red wavelength. Absorption and emission of light by objects that are bounded, say electrons, in a box, have certain energy levels, therefore certain absorption and emission frequencies.